Alright, this is a quick little intro for the lab on Newton's law. And one thing I want to note is don't forget this question mark right here. For some reason, people seem to forget this guy. What we're essentially going to be testing in this particular lab is we're going to prove that forces cause acceleration and more force causes more acceleration. I'm going to pop open a quick little list of some lab materials as well as some things to be careful of. First of all, the motion sensor. Y'all have used these before, so I'm just going to pop open a picture of that very quickly just now. Then we're going to use a force sensor. Now I do want to talk to you a little bit about the force sensors. Right here we have the force sensors, and you can kind of see that there's a setting for 10 newtons or 50 newtons, and this just kind of adjusts the sensitivity of these guys. Lab4 does not like it if you flip the switch in the middle of the lab, so make sure it's on whatever setting that the lab tells you to put it on before you plug this thing into Lab4. A couple of other things to note is on the end of this there's a little rubber stopper thing, but also in the box there's a hook and a post, and these things live inside the box. Please put them back inside the box when you're done. For this particular lab, you're going to take off the rubber stopper, you're going to place it into the box, and you're going to take the hook and it's going to screw into the end where the rubber stopper was. At the end of the day, please make sure that all the stuff that lives inside of this box goes back into the box. You also need a track. They are all around the room, kind of behind the computers, about shoulder level. And you also need a cart. I'm going to pop open a picture of a cart just now. You need a level, and I'm going to pop open a picture of where the levels live. They kind of live in the front of the classroom on one of those white cabinets. You need a piece of string. About a body's length is what you need, and the string will be at the front table. You need some washers that live in the Maxwell house can that's going to be on the front table. You need a research grade paper clip as well as a pulley. A couple things to be careful of is the very first thing you should do is you should level your track. It's very important that we don't have a ramp. We want to have no influence of gravity in this particular lab. We also need to make sure that we zero the force sensor, because if the force sensor is not zeroed, then, well, bad things are going to happen. So please make sure you zero the force sensor, and make sure that you're not yanking on it or pushing it or anything like that when you zero this thing. So what you're going to do is you're going to connect the motion sensor to the dig side of the white or green box, and the force sensor to the comm side. Now what this translates to is if it doesn't fit in one side, it goes in the other side, and don't force it if it doesn't fit. The force sensor and motion sensor do go on different sides of those boxes. Then you're going to attach the force sensor to the cart, and you're going to do that by using that rod that lives inside the force sensor. I'm going to show you a picture of first the cart with just the rod on it, and then you're going to go ahead and take a look at the picture of the force sensor sitting on top of the cart. You're going to fire up Lab4, and please make sure you zero the force sensor. You're going to mess around with the sample rate, and then you're going to just make a quick prediction. What's going to happen if I pull on this cart with a force? What's the velocity and what's the acceleration going to look like? Again, with all predictions, I don't care if you're right or wrong. I just want you to make a prediction. You're going to set this thing up kind of as such, and it really does look like this. I'm going to pop open a picture of what the setup looks like. We're going to have the perfectly level track. We're going to have the cart on top, the force sensor with a string running from the hook around to the pulley, and then to the hanging mast, which is going to be one of the washers. What we're going to do is you're going to let this thing go, and you're going to sketch the velocity, acceleration, and force graphs right here, and then you're going to record the average force by using the statistics button. Now we're also interested in the acceleration, and the acceleration versus time graph is a little bit bumpy, but we know that the slope of the velocity versus time graph is the acceleration. So what you're going to do is you're going to just fit a line to the portion of it where the mass is falling and record the acceleration there. Then you have a couple of questions to answer, and what we're going to do is essentially increase the number of washers, increasing the force, therefore increasing the acceleration. So essentially what you're going to do is you're just going to repeat the activity. You did one washer, you can use your results from activity 2 right here. No washers, probably no force, probably no acceleration. That one's a no-brainer. You're going to increase it to 2 washers, 3 washers, and 4 washers, probably increasing the average force, also increasing the average acceleration. When it comes to the mass of the washers, what you're going to do is you're going to measure them using the scale that's in the front of the room. I'm going to pop open a picture of that just right here. Then what you're going to do is you're going to start to graph this thing. Now, in order to graph it, you're going to open up a new file in Logger Pro and do some manual data entry. Just a quick little tip, when it comes to doing manual data entry, the computer does not like it with the USB plugged in and detectors plugged in. You can force it, but the easiest possible thing to do is just unplug the USB, and then it's going to immediately open up a new file that you can just start putting stuff in. What you're going to do is you're going to put the force on the y-axis, and you're going to put the acceleration on the x-axis. Essentially, we're going to be plotting the force as a function of the acceleration. What we're going to do is we're going to fit a line to it, and probably not surprisingly, if we say y is equal to mx plus b, then if force is on the y-axis and acceleration is on the x-axis, the slope of your line should be the mass of the cart. Then what you're going to do is you're going to measure the mass of the cart using the scales in the front of the classroom, and how well does it agree? It should be close. Not perfect, but close. One thing I wanted to note is when you measure the mass of the cart, these carts have wheels, and I highly recommend that you put the cart on upside down. When you measure the mass of the cart, bear in mind that it's going to be the mass of the cart plus the mass of the force sensor. So make sure that the force sensor, the post, and all that good stuff is still on the cart when you make that measurement. Then what you're going to do is you're just going to skip ahead to the next part. All this bits with free body diagrams and so on and so forth. You can do that on your own, or you can do that after you collect your data, but you cannot collect your data when the class is already over. So all of that right there you're going to do later. All of this right here you're going to do later, and you're going to do that later. You're going to pick back up just right over here. You're going to increase the mass of the cart using one of these weights that I'm going to pop open a picture of, and I'm going to show you a picture of it on the cart. I do have some fancy things to strap it to the cart with, but what I found is just a little piece of tape is going to hold it on there just fine. So you're going to repeat the activity with 0 washers, 1 washer, 2 washer, 3 washer, and a different mass of the cart. Again, you can only do this in the classroom, so I would do this before you do any of that stuff that is above it, because you don't have Logger Pro on probably your home computer. You're going to do manual data entry, plot the force versus the acceleration, and say, wow, look at that. It's a steeper slope, it had more mass. You're going to measure now the mass of the cart, the mass of the force sensor, and the additional mass, and how well does it agree.